So the last thing we're going to talk about today is to kind of step back from all the things we've seen and evaluate Java-structured concurrency. Now that you've had a chance to see it being applied in a couple different use cases, and you've seen it compared and contrasted with parallel streams and completable futures and project reactor, reactive programming, and so on. So here are some benefits of structured concurrency. It arguably provides greater clarity to the structure of concurrent code, especially compared against sort of free threading, where you can spawn threads any old way you want. Maybe not so much in terms of those other frameworks we've talked about, because they also constrain things in various ways. But you always know that you're going to have sort of parent-child relationships between the invoker method and its subclasses. So whatever method is up here, like let's say we had a method called handle or send response or something like that, these are going to be children subtasks that do the work in the context of the handle scope. So that gives you more structure. The whole block of code here, the handle code, that all becomes atomic. So this whole thing runs as a unit. If something goes wrong, then if one of these things throws an error, the other one will be canceled automatically, so we don't have to worry about that. We can be interrupted. If something interrupts this, then the forks will be canceled automatically when the scope exits, and the exception will be thrown appropriately. Arguably, it is easier to reason about and read the code because it looks pretty much like single-threaded computations. Find the user, fetch the order, send the response. This is where I think they're overstating it a little bit because there is a bunch of ceremony going on here that you wouldn't have with code like this. But on the other hand, once you get used to it, you kind of your eyes kind of ignore all the ceremony stuff and you just focus on the things that matter, especially if you color code it like I do on my slides. Another nice thing about Java-structured concurrency is it supports both invoke all and invoke any semantics. So we saw before where you can invoke everything and wait for them all to finish. That's the shutdown on failure model. Or you can use the thing where you invoke a bunch of calls and you take whichever one finishes first. That's the invoke any or the shutdown on success model. But of course, there are some downsides. And one of the things I don't like very much, and I think I've hopefully made that fairly clear in the examples, is this use of future as a syntactic means of keeping track of the results of forking stuff is a bit awkward and limiting. So what do I mean by that? Well, let's take a look at the example we've seen before a couple times where we're going to quick sort something and heap sort it at the same time. So the idea here is to sort the list in parallel and print the results. Well, one of the annoying things, and this is, in fact, it's so annoying that I had to keep I couldn't show all the code on this one slide because it would run over unless I use my helper method here. We have to take the results that come in as a list of futures to big fractions and turn it into a list of the results. So that takes time, and it's also just ugly, which is why I wrote the little helper method, but even so, it takes time. So you got to do those conversions. Another thing that's a limitation is that by using futures, we can't use all the really cool completion stage methods that completable futures provide to be able to chain together the results of these asynchronous calls. I sort of know why, but it's a shame that they chose to use future as the returns from the fork method as opposed to completable futures. Completable futures can do a lot more things that futures can't. Futures are very heavily limited relative to completable futures. So that's kind of annoying. The reason why they did that is they were trying to have a fairly simple, in quotes, model that didn't require people to learn all about completable futures. But still, it's a shame because completable futures are really cool. The other thing that I kind of find annoying, and I pointed this out, is that the syntax is a bit verbose. So especially if you go back and compare and contrast with the parallel streams example we looked at, or even the project reactor implementation we looked at, where the syntax was pretty straightforward. We could kind of put everything in one nice little flow, one nice little chain of fluent interfaces connected together and so on by intermediate operations. The way it's done here is just more stuff. So we've got the try with resources block, we've got the scope thing, we've got forking and joining and results. Not the end of the world, of course, but it's just extra stuff And now it has good reasons to be there. I mean, it plays a very important role in providing the features of structured concurrency, but I just find it syntactically dense. And compare that with completable futures. So here's the approach using structured concurrency with shutdown and success. And like I said, I didn't even have a chance to do the heap sort example because it would have run off the end of the slide. And here's the same code with completable futures. And I just think it's more concise. So you asynchronously quicksort, you asynchronously heap sort, and you accept whichever one comes back. Boom. So it's a little bit more concise. And interestingly enough, doing this kind of thing with parallel streams is harder. It's doable, but it's not as convenient as what we're showing here. So anyway, that's kind of the end of the discussion of evaluating structured concurrency. Be aware that it exists. You may be in a situation where you're needed to use it because people building microservices, which is a very common use of Java, and backends, as we'll see with more focus on Spring as we go through the course, and Spring Web MVC. This is a common model I think we're going to see more of. I think we're going to see a lot more interesting focus on virtual threads, which gives you an alternative programming model that gives you the benefits of synchronous programming without some of the traditional downsides with synchronous programming, like running out of threads or having heavy overhead from using platform threads. But be aware that there are other models. And so throughout the course, you'll get a chance to compare and contrast the other models, and you can decide which ones you like the best.